Hello everyone, let's look at this equation with three different trig functions. This one has the secant x is equal to the tangent x plus the cotangent x. And so because they're all different trig functions and there is no squares on them, so it's really hard to just turn one into the other without having to deal with square roots. So in this case, the easiest way in general is just to convert all of them into sine and cosine. So we only need to worry about the sine and cosine functions. Okay, so let's try this. So first, we are going to rewrite the secant x as in terms of cosine, right? So we are going to get the reciprocal of the cosine. So that's 1 over. Okay, I'm using the wrong color here. It will be 1 over cosine x. And that's equal to the tangent x is actually the sine x over the cosine x. And then plus, now what about the cotangent? The cotangent would be the cosine x over the sine x. Yeah, so now we have that equation. As you can see here, the three terms, they don't really have the same denominator, so we cannot just combine them all together. Even though we can combine those two terms, but there is still this fraction right here that we still need to worry about, right? So one easy way to do it is to eliminate the denominators by multiplying every fraction by the LCD. And so let's first write down the LCD. The LCD is going to be, in this case, would be the cosine x and then the sine x. Okay, so we multiply each term by the LCD. So we are going to get an expression that looks like this. 1 over cosine x, and then times this LCD right here. So we are going to get cosine x sine x, and that's equal to sine x over cosine x, and then times the same LCD, and then plus. Next one is the cosine x over the sine x, and then times the LCD as well. So in this case, we are going to start doing the canceling. And for the first fraction right here, the cosines will get canceled, right? So we can cancel the cosine. And then for this one, the cosines will get cancel the cosine. And then for the last fraction, the sines will get canceled. So we're going to cancel the sine, right? And they all become a 1. So we're left with just the sine x on the left-hand side of the equation. How about the right-hand side? The right-hand side is sine x times the sine x, which will give us sine square x plus. And then the other one is the cosine x times the cosine x. That will give us the cosine square x. And it turns out that there was an identity telling you that you can rewrite this into an expression that's even simpler. Sine square x plus cosine square x is actually just 1. So we get sine x is equal to 1. Okay, so now that becomes a really simple equation. And the one here tells you that the x would be a quadrantal angle. So in this case, we can just consider the xy plane. So let me just draw that quickly. I can just draw it on the side right here. And the question is, how do we get 1? Remember, this is supposed to be the y value, right? Because its sine equals to this number. So it will be a y value in this case. So just remember that this is the y value of the point that lies on the terminal side for the angle. And because if we want the point that has a y value of 1 on the unit circle, then it's going to be what? There is only just one point on there, which is this point. Which is what? This point is actually 0, 1. So now you can see that the y value for this point, it's a 1, right? So that will be the only point. And in this case, as you know, because it's lying on the positive y-axis, so the angle that we are having is just pi over 2. So that's 90 degrees. Is that okay? So now you may say that, okay, so there's only one solution. We're going to box this answer. But the problem is we need to check because by multiplying everything by the LCD, we're assuming that cosine x and sine x is not equal to 0 for the original equation. But here comes the problem. When you plug this pi over 2 back into the LCD, which comes from the denominator, it's going to make the cosine x equal to 0, or you can actually just plug the pi over 2 back into the equation, right? And then you can see that the secant x, or secant pi over 2, when you plug the pi over 2 into the x, is actually undefined. And so what does that mean? That means this solution is an extraneous solution. Let's just write it here. Two ways to do the checking, right? So one way to check is that we can just plug it back into the LCD and we check whether it will make it 0, because if it makes the denominator equal to 0, then it will be a problem, right? So if you just check the LCD right here, so that's one way to check it, is that the cosine of pi over 2, right? So you plug this back in there, so pi over 2, and then same thing for the other one, which is the sine of pi over 2, right? Sine of pi over 2 has no problem because sine of pi over 2 is equal to 1. But cosine of pi over 2 is 0. So this thing is actually equal to 0. So that tells us that this solution is extraneous. Or you can simply just do something else like this. So if you plug it back into the original equation, you check the left-hand side of the equation, right? The LHS stands for the left-hand side. The left-hand side of the equation is secant x, but the secant x is actually just pi over 2, right? If you plug that in there, then there is no value for this one. So this one is undefined. And so from the checking, both cases, right, it doesn't matter which one that you check, it tells us that this solution right here, this is an extraneous solution. And so what does that mean? That means we got to cross out the solution. But that's our only solution and we cross it out. So what does that mean? That means the equation has no solution. So we write down our conclusion here. So the equation has no solution. And then we have, that's our conclusion. Okay, so that's it for this video. If you like my video, please subscribe to my channel and give me some support.